Hi, welcome to the State of the Union 2022. I'm Isabela Fernandes, the Executive Director of the Tor Project, and your host for today's stream. Every year, we at the Tor Project organize this stream to share with you an update about the work we did during the year and the cool things we will do in 2023. I'd like to thank everyone who's joined us today. Welcome. This year, we will do things a little bit different. Today, we will be broadcasting the presentations of the teams working at the Tor project. And next Wednesday, November 16, at the same time, 1700 UTC, our community will be the one presenting. You will hear from other organizations and projects that are part of the Tor community, where they will share about the work and how you can support them as well. But today is about the Tor project team. 2022 has been quite an intense year for us. Throughout the year, we have been dealing with different cases of censorship against Tor. We started the year already being blocked by Russia. Then, with the Ukraine war, the cases of censorship spread throughout the region. Our teams will share about the hard work that they did to fight these censorship cases. And our community, you, play a big role in all of this. Without your support, we couldn't do it. People ran bridges, made donations, installed Snowflake extensions to the browsers, educated others about Tor, and did so much to help us succeed in providing safe internet access to those who need it. In the United States, after Roe versus Wade was revoked by the Supreme Court, we saw a whole group of people, millions of people, losing their rights and being at risk from one day to another. People who need a way to safely look online for reproductive health care. When the protests in Iran started, the same mobilization we have seen in our community all year long happening again. Tens of thousands of people help us provide a way for Iranian protesters to get online and share about the struggle. This is incredible. Thank you so much for supporting the technology we build, supporting our work, and for helping people have access to Tor so they can safely use the internet. We have been dealing with other challenges as well. There is a DDoS attack slowing down the network, and you probably have noticed it. Our teams will talk more about it too. And to be honest, I don't think our challenge will ever end. However, it is possible to overcome that, as long as we are not trying to do it alone. Everything that happened in 2022 shows how important it is to have such a united community where we support each other. It shows how strong we can be together and how capable we are of overcoming any challenge. So thank you again for your support and for being with us. Now, let's get this State of the Union started. I would like to start by inviting Gus, our community team lead, to share about his teamwork. So please join me and welcome Gus. Hi, Gus.
Hello, Isa. Can you hear me?
Yes.
Okay, let me share my presentation. 1 second. Yes, here it is. So, hello, this is Gus from the Tor Project. I work as the community lead, and today I'm going to cover very quick what we have been doing this year, fighting against the internet censorship around the world. But also, I'm going to introduce a little bit about the new Tor support channels that we have, and the meetups that we organized, and some trainings that we did. So this year, as Isa was saying, we were surprised by the number of censorship events that happened, not just in one country, but around the world. We started the year with Tor getting blocked in Russia, but also right now we are having some internet shutdowns and Tor blockage in Iran. And one thing that we have noticed is that email is great, it works, it's nice, but people in the global south are using messaging apps like WhatsApp, Signal, and Telegram. So one thing that we did this year was to launch new support channels on these messaging apps. So we have Telegram bots that you can get breeds and get Tor browser binaries, and you can also request for help. Just to give you some idea of how much work we did this year, since the last State of the Union, we helped over 9,000 by email, 9,000 folks by email, and 9,000 folks by Telegram Signal. Just to give you a scale of this work, previously in 2019, we helped like 1,000 or between 1,000 and 2,000 folks. So it's a lot of work that we have been doing, and this is important for the user feedback that we are building. So basically, people report that Tor is not working. Tor user support team check that and help you to debug what's the issue. If it's a censorship filtering or a new censorship event that's happening, we start the investigation and share this user input with Tor browser developers and also with the anti-censorship team on Tor. So with that information, we can build Tor training guides. We can build a better product to bypass censorship. And we also helped users in Iran. Tor browser and our bot was very used by the protesters that started in September. And also Snowflake is a very important tool to bypass censorship in Iran. Just to give an example, we jumped from 300,000, 30,000 Snowflake proxies in March this year to 100,000 Snowflake proxies. So this is glad to your work on the community that are spreading this information around the road during protests, but also recording videos on TikTok explaining others how to install a Snowflake extension. So this is very important, and I'm very happy to see the community doing this and supporting people to access the free and open internet. As the pandemic is still ongoing, we did some work online and offline with the community in the Global South. We organized Tor activities like trainings, meetups, one-to-one events, like teaching other folks about Tor. We organized 4 meetups in the Global South, and over 700 people were reached by our activities. We also had the relay operator community organized a Tor training bridge campaign. We organized 6 relay operators meetups. We did some work with the network health team to reject bad relays. And we also have our next relay operator meetup next week. So feel free to join us. It's open and free, and you don't need to register to join this event. And what's up next year? We are going to continue to support our users to bypass internet censorship. We are going to launch a WhatsApp user support channel. We are going to continue to run our trainings in the Global South, especially in Latin America and East Africa. And we are going to continue to move our translation from Transifex to Weblate and localize our user documentation on more languages, in Arabic, Farsi, Russian, Swahili, and Chinese. And also part of our work to improve to improve the Tor relay operator community, we are going to build more policies and agreements so we can reject bad relays and build a trusted relay operator community. And we also have some work to do on a new Run a Tor Bridge campaign that we are expecting to have a new pluggable transport, and this is upcoming for the next year. So thank you a lot for running Tor, for helping our community, for helping us to understand the censorship without you, without the Tor community. So thank you a lot, and back to you, Isa.
Thank you so much, Gus. As you all saw, these amazing numbers that Gus just shared with us. So now I'm very happy to invite Matthew, our anti-censorship team lead, that can talk about their work and how this all connect back to the anti-censorship team. Hi, Matthew.
Hello, thank you, Isa. So yeah, I'm Mesquio. I'm part of the anti-censorship team at Tor. As Gus has already introduced, it has been a very intense year, this 2022. Like we started the year seeing how the tensions in Russia was creating a situation where Russia started blocking Tor and many other services online. We've seen how countries like Kazakhstan answered to demonstrations by blocking almost completely internet on the country for several days. Or we have seen the situation in Iran where many services has been blocked, or even in some regions the internet has been shut down. So as you can understand, in the team, we have been working very hard to make it possible to connect to internet in all these places. And at the same time, we try to balance all this work on planning and creating the tools that we will need for the future situations that will come. You might remember that last year we introduced it as Snowflake, this new pluggable transport that was shipped already in Tor Browser last year. This year has been the year where we actually battle tested. Like many people has been relying on a Snowflake to be able to connect to Tor from many different places on the world. The same way, we have seen how sensors has started to notice that Snowflake exists and has started to react to it. Like we've seen how places like Russia has started to figure out ways to block and distinguish snowflakes from other traffic on internet. And that has made us work hardly into figure out ways to make it more robust, the protocol, and make it harder to detect. And we have done a lot of improvements on that. At the same time, we have seen this rise of usage, like in Iran, in the last couple of months, we have seen how the usage of Snowflake have increased heavily, in a sense that the network has been struggling to handle so many users. We knew from the beginning that Snowflake had some bottlenecks, like there is a single bridge that holds all the traffic of a Snowflake. So for the last year, we've been working, preparing ourselves to get ready to be able to have multiple bridges. And the current Tor Browser Alpha already has a second bridge integrated. But at the same time, there has been a community of volunteers working heavily on keeping up this bridge and making the hardware able to handle as much as the users as possible to be able to keep up with this huge increase of usage that we've experienced over the year. So for the last few years, we've been using BridgeDB as our main distribution system for bridges. We've been working on parallel creating a new distribution system that we call RDCs. This year we deployed RDCs, and it came with many interesting new tools that are helping us on anti-censorship. One of the cool things that we have developed in RDCs is something that we call the Circumvention Settings API. It's a service that Tor Browser and other applications use to get the settings that they need to configure to be able to avoid censorship in different networks. That allow us to very fast adapt to the changes and see and react to how the sensors are blocking things and decide what kind of pluggable transport or what kind of configuration of the pluggable transport works in different countries or in different networks. As Gus has already mentioned, we have also created like a Telegram bot to distribute bridges in places like Russia. We've seen how the sensor has been keeping up very fast on blocking bridges that we distribute. So we have experimenting on new ways to distribute bridges that will allow us to provide better bridges to actual users and to detect the sensors when they are trying to list the bridges. And one of these mechanisms is the Telegram bot. The same way on Telegram now we are distributing Tor Browser. So in countries where our website is blocked, people can download Tor Browser directly over our Telegram bot. So what is coming up for the next year? So we are preparing new pluggable transports. Like we are working on a new pluggable transport called Conjure. Conjure is a pluggable transport that allows us to make a relation with an ISP, so we can use their unused IP addresses to tunnel Tor traffic. At the same time, we have created also a web tunnel that is a pluggable transport where website administrators can create tunnels on their websites to connect to Tor. So the Tor traffic looks like visits on their website, and it's hard for sensors to distinguish which connection is Tor and which connection is just a visit to the website. The same way, we are figuring out new ways to distribute bridges, and we are working in something called Salmon, that is a social network-based distribution mechanism, so we can build trust on the users and decide what kind of bridges we give to different users. but many new things might happen on 2023, and we need to be ready for all of them. I want to say thank you here for all the community that has helping us to figure out how things are happening in different places. If it was not for the community, we will not know. And it's been an amazing collaboration with many people. So thank you, and see you around.
Thank you so much, Matthew. Yes, thank you so much, Matthew. And another way that people also bypass censorship is using Onion service on the website. I would like to invite Raya, our Education Communities Coordinator, to talk about our work on onionizing the web. Welcome, Raya.
Thank you very much, Isa. Thank you very much. Yes, we're going to talk about Onion services and the work we've been doing in the past year, as well as some of the things we're planning for next year. All right. So just for a recap, Onion services are basically websites people visit within the Tor network. People never leave the Tor network when they visit an Onion service. It's an end-to-end encryption communication, and you're meeting inside a rendezvous point within the network. Just as a recap as well, there are Onion services everywhere now. Media outlets have deployed, including The Intercept and the BBC. Social media networks, you can now run entire email services in your entire social media via an Onion service to ensure anonymity. Human rights organizations, including Freedom of the Press Foundation, Privacy International, but also whistleblowing software like SecureDrop and Global Leaks. And so, yeah, you can also visit the website and the Onion address just by going to the website itself, clicking on the purple pill on the right-hand side of the URL bar, which says Onion available, and it will lead you to the Onion service or the Onion counterpart of the website. So some of the things we aim for with Onion services, some of the things we've already built, but some we're hoping to happen. Is built-in resistance against surveillance and censorship, specifically traffic surveillance and specifically network censorship. This is something that already happens with Onion services. Another thing we're hoping to have within Onion services is resistance against DOS attacks. Something that's already been implemented, like I said before, is end-to-end encryption between the user and the service. There's also a very big address space. It's, I believe, 56 characters followed by a .onion. There's no allocation authority. You don't need to purchase any domain from anyone. There's also what we're hoping to have is support for multiple pluggable naming systems, so it's just easier to memorize the addresses and visit them. And the overarching goal is that all of the above works as an anonymization layer. All right, throughout the year, what we've been doing with Onion service, from planting, growing, and harvesting Onion services, things we have no responsibility over, but we're very happy that it happens, are Onion services that were deployed in 2022, including the most recent one, which is Reddit's, Twitter, that published its Onion service back in February following the invasion of Ukraine, and also The Guardian, who happened to publish an entire blog post detailing the developer's experience and the sysadmin's experience for deploying and then maintaining the Onion service for The Guardian. All right. So in 2022, we did a lot of work. Something I think that this is the first time that the Tor Project does is deploy Onion services for other folks. We deployed over 90 Onion services for media outlets. We also trained journalists and media staff on everything that has to do with Tor and Onion services. And we built open source tools to support with the deployment of Onion services. So one of them is Onion Probe. So it's an open source tool to monitor the uptime of services to make sure they're up and running and they're not down. You receive an alert if anything's happening, and it can help with diagnosing issues. There's a GitLab link here if you want to visit the repository. Try it yourself as well. The Onion Launchpad is just a customizable landing page. If you have an Onion service today, you can just take the Onion Launchpad and then use it to advertise your Onion service to your audience. It has text in over 61 languages explaining what are Onion services, what is Tor as well, and how to access them. And here's the GitLab link as well to visit the repo. Okay. The Onion plan, I think it's something we're very excited about, is what we're planning for moving forward with everything that has to do with Onion. So Onion, onwards, Onion words. If you can come up with a good pun, I'd be very happy. So the goal is increased adoption of Onion services. This is what we're hoping to do, is maybe normalize Onion services in a way that HTTPS was normalized today, that it's everywhere. So this can only happen if the user experience is enhanced for both the users of these Onion services, but also the service operators, those who are deploying and maintaining the Onion services. What we hope to do is better outreach, write better guides, draft more training resources, but targeting both the users and the service operators, doing more training and awareness sessions. We've done a lot this year. We hope to do many more in the coming year. Actually, there's one on Tuesday in Bread and Net in Beirut that's going to be live, and we're going to talk about Onion services, and also do usage and adoption campaigns similar to what we did previously with More Onions Por Favor, and maybe do it just on a wider scale. Tooling, we want to integrate with existing tools, because currently Onion service deployment toolkits, they're not very well integrated with what software development tools already offer. And so this needs to happen, and it needs to happen fast if we want adoption to increase. And also building more tools like what we did with Onion Probe, Onion Launchpad. We also had deployed Onion Mine for vanity key generation, then hoping to get Onion Groove up and running. And finally is usability. The main goal is to have memorable and human readable Onion addresses, because as we said, they're a very long string of characters followed by .onion, which I think is very difficult to memorize unless you memorize pi. Currently, I believe SecureDrop uses Onion names, and the goal is to maybe generalize this across all of Onion services via different things, different strategies we're exploring, and also trying to link traditional addresses, or what we call traditional addresses, with their Onion service counterparts. And really, that's it. And if you have any questions that has to do with Onions, you can contact either Rat or myself on these emails, or just find us on the forum, on the Tor Project forum. And thank you very much.
Thank you so much, Raya. And as everybody can see, there's a lot happening on the Onion service world, and we will continue to do it, just like we did with other areas at Tor. Little by little, we increase investment, right? Like we did with anti-censorship and network health. Now it's Onion service time. So very excited. Now I want to invite Duncan, our UX team lead, to talk about how we're improving our users' life as they're using Tor. Welcome, Duncan.
Thanks, Isa. Hi, I'm Duncan, aka Donuts. I'm from the User Experience and Design team. Today, I'm going to share a recap of the user research we conducted in 2022, the UX improvements that we shipped this year, and then a little bit about what's coming next for Tor browser and beyond. Starting, of course, with our ethical user research program. So this year, we managed to conduct 31 user interviews, 19 of which included moderated usability testing of Tor browser. And in addition, we helped onboard 7 trainers to conduct usability research on our behalf. And we collected feedback from 256 participants of digital security training workshops. So participants from this research spanned 13 countries, primarily across the Global South. But we did also collect feedback via our user support team from users in censorship hotspots, including Belarus, Russia, Iran, Turkmenistan, and mainland China. This year, we learned that quick, super friendly solutions like Connection Assist come in really handy in response to rapidly developing censorship events. And secondly, there's an increasing demand for training and support for mobile users. Thirdly, user perception of Tor is changing as technologies like VPNs become more commonplace too. Moving on to the UX improvements we shipped this year. Our first major release of the year, Tor Browser 11.5, landed in July. That release included Connection Assist, a new feature that helps censored users circumvent blocking of the Tor network at the press of a button. It does that by using the circumvention settings API that Meskio mentioned earlier to essentially try and apply the bridge configurations we think will work best in the user's location for them. We also shipped a redesign of Tor network settings, now called connection settings, and the changes here include a new connection status section, bridge cards to visualize the bridges that you've got configured, and the process to add a new bridge has been streamlined too. Starting in 11.5, HTTPS only mode has been enabled by default for desktop, and we've also bundled more fonts which protect against fingerprinting by font enumeration to expand the number of writing systems supported by Tor browser. Now, the user journey of circumventing censorship involves many touch points besides the browser, and one of these is bridges.torproject.org, which I'm pleased to say has received a UX and visual update to make it more consistent with our other websites this year. Similarly, we created these fun avatars for our Telegram bots, which help censored users download Tor browser, find bridges, and get support. The team has also contributed to the design of a bunch of other things too, including a new logo for Arty, the look and feel of our year-end campaign, the Bug Smash Fund, and the Tor Project's 2021 annual report. We also ran a campaign aimed at recruiting more alpha testers. So as a small nonprofit, we rely on our community testers to identify and report bugs with Tor Browser Alpha. It's one of the most accessible ways you can contribute to the Tor project, and I'd like to encourage anyone who's interested to download Tor Browser Alpha and start testing today. So what's coming up next? Well, thanks to the hard work of our applications team, our next major release, Tor Browser 12, is coming soon. Richard will cover this release in more detail later, but I wanted to highlight that this will be the first multi-locale Tor browser for desktop, meaning all supported languages are now included in a single bundle and can be changed without requiring additional downloads via the language menu in general settings. This release comes with dozens of other fixes too, such as a universal bundle for both Apple Silicon and Intel-based Macs, Ukrainian locale support, and much more. We're also working on a number of things that won't be ready in time for Tor Browser 12, but that you can still look forward to in a later release next year. Those include refreshed application icons for Tor Browser, an update to Firefox's most recent onboarding experience, a simplified, more modern start page, even more usability improvements, and we're making an effort to improve Tor Browser's accessibility and screen reader support wherever possible. New things, I'm pleased to say, are coming to Android next year too, including Connection Assist for mobile. And beyond Tor Browser, we're currently working on a new and improved version of our download page, preparing it to house multiple apps in future. Lastly, we're expanding our Tor icons into a full icon set that can be used by many different Tor-powered apps, including the future Tor VPN. Thank you very much to everyone at Tor and in the community who helped make these improvements happen this year. That's it from me, so back to Isa.
Thank you so much, Duncan. And yes, the UX team have done so much this year. And this is the team, right, like that brings to us the voice of the user. And now I want to bring the engineer side of it. I would like to invite Hishit, our applications team lead, and who is going to be talking also about the work we'll be doing on Tor browser. So please welcome Hishit.
Hi, my name is Richard, and I'm the applications team lead at the Tor Project. And today we're going to be talking about the state of Tor browser. So the things I'm going to try to cover is some team updates, the Tor browser 11.5 release, the upcoming Tor browser 12.0 release, some development quality of life improvements that we've made over the past year, and a call for alpha testing. So over the past year, our team has grown to 6. These are our IRC and GitLab handles. You can come find us at the Tor Browser Dev channel on OFTC IRC. So if you want to contribute or volunteer or submit patches, come find us, come chat, we're friendly. So in July of 2022, we released Tor Browser 11.5. This featured the automatic censorship detection and circumvention system, which you access through About Tor Connect. This allows users who are trying to connect on censored networks to bootstrap and connect and determine what settings work for them in order to bypass their censorship. We redesigned the Tor network settings in About Preferences. This is a general UI improvement and also allows users to share bridge lines more easily. We enabled HTTPS only mode by default and removed the HTTPS everywhere extension as it is now no longer needed. And finally, we bundled more fonts to add better support for people who use different writing systems. Tor Browser 12.0 is scheduled for release at the end of November 2022. This will feature a migration to ESR 102 for both desktop and Android. This is a bit different to how we've done things in the past. Traditionally, the Firefox release has always followed rapid release, which updates every month, whereas now it'll be on ESR 102, so it'll basically be locked on the 102 version of Firefox for Android, while still receiving sort of ESR updates and also be backporting any CVEs for security issues that happen in the rapid release train. So it'll continue to be getting security updates, but should provide us with a little bit of stability. We added support for multi-locale bundled packages. So this means that every locale will be bundled in a Tor browser instead of having to, go and download the Tor browser bundle that is specific to your locale. You'll just download one, and then you can pick your language for runtime. We have added support for universal x86-64 plus Arch64 packages for Mac OS, which basically means that if you're a Mac OS user, you can download one bundle and you will have a native experience. We are in the middle of an accessibility audit for all of our sort of custom Tor browser UI with an eye towards improving accessibility. So if you are a user of a screen reader or other sort of accessibility technology, future Tor browser updates should work better for you. And of course, there's just the various fingerprinting, security, and privacy updates that you kind of come to expect of any Tor browser release and bug fixes as well. And finally, the thing I'm most excited about is the sort of development quality of life improvements that we've made over the past year to sort of improve our sustainability and sanity. We've drastically improved our release process. We have much better automation and scripts and documentation. We've converged the Android and desktop source code, so that means less rebasing. But it also means for our end users that any sort of Tor browser feature or protection that is provided in desktop Tor browser, so long as it doesn't require a UI component, Android users will get that update for free. We are trimming and integrating legacy components, so Tor Launcher is now no longer a thing. We have integrated or re-implemented the required functionality in Tor browser itself, and Tor Button is going to have a similar treatment in the 12.5 series coming next year. We've improved our patch bisectability. This basically means that you can take any commit in the Tor browser source tree, check it out, build it, and run it. What this means for the development cycle is that bugs should in generally be easier to figure out where they came from, just because now you can check out any commit and run it. And of course, multi-locale bundles, good for users, really great for the release process. So we support 36 languages, which means in the stable series, we are building 36 copies of everything. So as a result, signing takes 36 times longer than it should. So for perspective, if a signing release process was going smoothly, it would take about 8 hours from the build finishing to actually signing, publishing, updating, pushing to servers, etc. The most recent alpha release, in comparison, that whole process took 27 minutes. So it makes my life a lot easier, to be sure. Finally, lots of stuff has changed. Come and be an alpha tester. We need testing, particularly around multi-locale bundles and on Mac OS if you're running the new sort of ARM hardware. Follow these links, come be an alpha tester. And, as always, just thank you for using Tor browser and thank you for contributing.
Awesome. This is what he shared, recorded presentation. So happy to see the developer life quality improving on this team. I think the team have done a lot of work on that, and we have brought in super amazing new people into the team as well. And like Duncan and Hisham mentioned, there's a lot coming up on browser, also on Android browser that you should be looking forward to. I would like to invite now Micah, our new director of engineering.
Hey.
To talk about VPNs. All right. Welcome, Micah. I'm going to pass the mic.
Thank you. All right. Hey. Hello, everyone. My name's Micah. I'm really excited to be here today. This is my first State of the Onion. I started working with Tor at the end of June of this year as the Director of Engineering. But I'm not new to Tor, as I've been a volunteer for many years. Some of the things I've been involved in you can see on the slide, but I'm not here to talk about myself. I'm here to talk about the Tor VPN project. So the Tor VPN project is a new project that we're very excited to be building here at Tor. It's a client initially developed for Android, but more platforms are planned. It will operate like a VPN. However, unlike a traditional one-hop VPN, it will be using the Tor network underneath. Also, unlike the Tor browser, which makes only your web traffic go over Tor, the Tor VPN additionally will make other application traffic use Tor, all in an easy-to-use, circuit-isolated way. Although the Tor VPN won't be able to provide the same level of anti-fingerprinting browser defenses the Tor browser provides, it does solve other use cases that users do need and want. This project builds on patterns that have come out of many hard-fought lessons that the Guardian project has learned over the years with their efforts around Orbot, and work done with the Leap project on the Bitmask and RiseUp VPN applications. We're working with both organizations as partners in this effort. We began this VPN project by engaging with existing users to understand both how they use and how they understand Tor and VPNs. We did that through a VPN survey, a discovery survey, to understand the audience, the demographics, the platforms and VPNs that people use, and how they use them, if they even use them. It also involved understanding their privacy, security, and anonymity needs. We were also involved in a features survey to determine the demand for what to include in the Tor VPN, and have been incorporating lessons, user research from the Guardian project, Leap, and the broader VPN research community. One highlight that came out of all this research is that users consider censorship circumvention as a feature of VPNs and consider Tor as an anonymity tool. This tells us that if we were to create a VPN that cares about users' privacy and security, while also providing anti-censorship features that protect the VPN from being blocked, like bridges, we would then be merging both of these needs, and this is why we're creating the Tor VPN. The high-level architecture for how this all fits together involves some moving parts underneath, including bringing UDP support to Tor, Arty, and Onion Mask. UDP support for the network is coming. It will require exit nodes to upgrade when it's available. It will let you run modern applications that require UDP support. And Arty, we want to use underneath everything because it's the modern way forwards for interfacing with Tor. Nick is going to be telling you more about Arty a little later today, so stay tuned for that. And then Onion Mask is something we've developed inside of Tor. Onion Mask handles dealing with isolating the low-level packets and state, congestion control, UDP aspects, and more. So basically the way this all works together is that the Tor VPN application starts and stops the TON interface. It funnels all the traffic on the device through that interface using Onion Mask as a proxy for that traffic, enabling us to call in and out of the Rust and Java world and isolate applications into different circuits, down into Arty streams, which then does its work to connect that traffic onto the Tor network through its hops and out to an exit node on the internet, and the same in reverse. What we will be doing next with the Tor VPN will be jumping into the wireframing process, and then we'll begin pulling all the pieces together with Android, Onion Mask, Arty, all the UI elements. We hope to have something that people can start playing with on their mobile and start providing feedback. Won't be something we want the public to use yet, but something to ask people to try and help us identify where traffic leaks happen or other issues so we can start iterating on that. I'm really excited about the coming year. It's a big one for Tor. We're completely overhauling the core of Tor's code with Arty, and that's proceeding at a brisk and amazing pace. This is incredibly meaningful for us as an organization, and we're at the same time also unlocking new levels of scaling on the network with congestion control. And the Tor VPN is going to be a defining change to the field. So I see huge potential for Tor this year, and I'm really humbled to be part of that future as it unfolds. And that concludes our whirlwind tour of Tor VPN. And thank you for coming to the State of the Onion. And I will turn it over to Isa. Over to you, Isa.
Thank you so much, Micah. And yes, everybody, welcome Micah to Tor. I wanted to just stop a little bit the stream to say, again, right, like how, like recap a little bit about all this amazing work that people are sharing with you, and to also say that you can support us. This is stream we do at the end of the year, which is also the time of the year we're doing your campaign for donations, and you can contribute as well. You can go to donate.torproject.org, make a contribution using your credit card, or you can also donate with cryptocurrency. You can also become a monthly donor if you go to donate.torproject.org/monthly-giving. You can see the address here on the bottom of the screen going on as well. It's so important for us to receive your contribution and for that contribution to be something for continuity, right? Like to have continuity and for the long term, because single thing that you heard here so far, every time that we had to stop everything to help a country, people in a country that needed to connect to Tor because they're facing censorship, every time that we had to stop, everything to fight a DDoS attack, all of these are shift of priorities on a day-to-day work that is paid for and sponsored for by donations, by unrestricted funds, right? That allow us to be agile and shift priorities. The other way, we are non-profit, so the other way we receive funds are grants of projects. So every time we need to drop this project and do something else, the support comes from you, from your donation. So it's extremely important that you support Tor and you make a donation. So again, you can go to donate.torproject.org, and you can donate with credit card, or you can donate with cryptocurrency. Everything is over there, super easy, and we really appreciate your help and your support. So now, to continue with the program, I would like to invite to the stage Georg. Georg is the network health team lead.
Hi,
He's
Isa.
going to talk about the work they're doing. Welcome, Georg.
Hi. Yeah, thanks. Let's talk a bit about network health. Let me see. We have an outline here for what I will be talking in the next couple of minutes. So first of all, there's a bunch of work we did in 2022, and then we have exciting news for 2023. So as you saw in the outline, fighting malicious relays is still a big important thing for us. We got help from the Tor browser team. It got mentioned earlier with the release of Tor browser 11.5, where an HTTPS-only mode got launched, which is helping tremendously with malicious access relays trying to snoop on users' traffic, which is a nice tool in our toolbox. It's growing, that's good. But just relying on technical tools is not going to solve the problem we have. So we started to invest our resources into a more holistic approach to detect malicious relays, which seems to pay off. If you look over the things happening over the year, which is pretty nice. If you want to check out what changes we did and where we originally came from, I wrote a blog post earlier this year, which you can read on blog torproject.org. It gives you an overview where we currently are. And of course, I mean, if you find a malicious relay or an attacker, please report them. It's still useful and helpful for having input from external people to make sure the network is staying safe. Another important area is the so-called end-of-life work, which means that we look at relays and bridges running outdated and unsupported Tor versions, because those are a danger to our users as they might contain unfixed security vulnerabilities. We developed the process over the recent years, which you can find in this GitLab link I included to these slides. Thanks to the help of a bunch of volunteers, this got improved. It is still a live document, so if you find there are things we should fix or make better, please report them. To give you an overview about what this looked like for this year, we had 2 cycles, one for the long-term Tor version 0.3.5 and one for the more recent one, 0.4.6. You see, we contacted like several hundred of relay operators and still had to reject several hundred of relays, unfortunately. You can see the weight of those relays in parentheses. It's okay, but we hope to have those numbers down in a couple of rounds in the future, because it's time consuming and we shouldn't be in the position to be contacting the operators in the first place, ideally. The final important pillar of our work was performance work. We moved all the bandwidth authorities to a new bandwidth scanner called SBWS, which is exciting because it allows us to build on top of that new features like potentially load balancing the Tor network better. And then we got hit by a bunch of denial of service attacks over the year. So we quickly tried to ramp up our DOS and analysis capabilities. For instance, we implemented metrics port improvements and other stuff. So if you want to check out what the latest situation is, I wrote an update to the Tor relays mailing list like 2 weeks ago. You can check that out and then get up to speed on where we currently are in this arms race. If you want to look at how this looks like with one of our tools, I can show you some graphs here. This is for the general overload of relays we saw in the past couple of months. So you see that in mid-July, a large amount of non-exit relays started to get overloaded massively. It was in the start of the denial of service attack. And then in the mid of September, exit relays were slowly ramping up as well for getting overloaded. And suddenly, like 2 weeks ago or so, both of those things stopped kind of simultaneously. We don't know what happened here. If any one of you knows, we are all ears. So if you have some news about that, please drop us a note. But so far, we keep monitoring the situation and try to work on our stuff, which we have on our plate to have a more sustained response to those incidents. So what's upcoming next year? We got a project approved for the next 2 years, which is keeping us likely busy in this time frame, which is very nice. It contains, broadly speaking, 3 areas of work. The first is improvements to the metrics pipeline. Hero will be talking later about that a bit more. And it will help us annotating relays entering the network, which is important so we are able to keep track on those, be able to cluster them to relays we know, operators we know, so we can finally start with our long-term goal of reducing traffic for relays we don't trust. Then the second part is related to fighting malicious relays as well. In our overall approach of not just relying on tools, we want to integrate the community tighter, not just the community team, the relay operator community, external people, because that's important. And we have some ideas and proposals here which we want to work and explore in the coming 2 years. And then on the more technical side, what we do is we finally catch up on a bunch of relay side attacks or side channel attacks. It's been in the literature for quite some years, explored some of those attacks, and defenses got proposed, but we never had time and resources to fix these things. And finally, it's time to get started on this backlog we had here. So that's all from my side. Thanks to everyone. And next up is, I guess, Alex. Yeah, first back to Isa. Thanks, Isa.
Thank you so much, Georg. Indeed. Next up is Alex, who is leading our network team. And hey, Alex. And it's going to talk about little Tor, which is still around, right? We still depend on it.
Absolutely, a little while there. Okay, let's see if my slides come up. Yes, awesome. My name is Alex. I'm heading up Tor's network team. We're the team responsible for doing the software little Tor, which is the Tor daemon that is deployed today in the network and in Tor browser and in different products that we use around. Additionally, our team is also doing other things. You will later see Jim talk about the shadow simulator and what we've been using that for in the past year. And Nick will also immediately after me talk a bit about Arty, our up-and-coming Rust implementation of Tor. So this year can be, we can look at some specific topics that have been important for the network team. We continue to ramp down on new client features that we see in the Tor implementation. We are greatly ramping up with the Rust development of the Arty project. We now have 3 people working full-time on this and a plethora of volunteers who are helping out. Micah already talked about the VPN work that is happening. We've been contributing to that from our team as well. Additionally, there are still people who currently need to integrate Tor into their product, and we're of course supervising those as well with the experience we have. Unfortunately, as Georg already talked a bit about, this year have also seen significant amount of denial of service, and that is something that the team has been working on. We still have done a few things on Tor. We have been working on our congestion control system. This work has been led by Mike Perry. And the team has been working across multiple different teams inside of the organization to implement and test different congestion control algorithms. We collaborated with both the shadow simulator, specifically with Jim, and also with the metrics team here. We evaluated various congestion control algorithms found in the literature, and we finally decided to settle for the Tor Vegas. This algorithm seemed to perform in the way that we expected from the theory that we knew. And if you look at these 2 plots, they're a little bit hard to understand, but if you look at the blue parts of the diagram, these are the version of Tor before congestion control was implemented, and the orange ones is after congestion control were implemented. The image to the left is a simulation based on a user in Germany, and the image to the right is a simulation of a user based in Hong Kong. And as you can see, the throughput that these clients are receiving seems to be much, much better when we have the congestion control in. We could see when we deployed the 0.47 version of Tor, which was released at the end of April this year, that we saw a significant increase in the amount of advertised bandwidth available in the network. We were very happy to see this. Unfortunately, the ongoing denial of service has made it significantly harder for us to test and look for tuning opportunities of the congestion control system in the production network. The team has been working specifically a lot together with the network health team, with Georg, to figure out what's going on with this denial of service and how the attack is sort of changing over time. Some of the things that we have gotten out of this that you will also see in the next version of Tor is that we've seen much better introspection tooling that has arrived inside of Tor, specifically via this feature that we call the metrics port. Metrics port allows you to receive data about what your relay is doing and how it's currently behaving in the network. David Goulet has been leading a lot of these efforts, and David last week shared this wonderful screenshot with me, which is a Grafana dashboard with one of the relays that we operate that we're currently spending some time shining up. This is something we are probably going to write out to the relay community about if people want to run something similar. And we also hope that the relay community will pick some of this up themselves and come up with awesome dashboards that can visualize some of these things that is happening with their nodes. If we take a look back to when 0.47 was released, one of the very important things that is in the Tor network is that we, the Tor project, is writing the software, but we have this wonderful community of relay operators who are running these nodes. Since we do not decide when you should upgrade and so on, we heavily rely on you being able to upgrade when we have new software out. On this plot, you see when 0.47 was released at the end of April, and we see a significant increase in relays that's coming out. We cannot thank the relay community enough for this. It is so important that we get new releases of Tor out in time, because it allows us to test the things that we're building in production, discover issues that exist with it, and try to fix it, ideally while our grants are still running. Which, yes, so thank you everybody who upgraded to 047. And for those who haven't upgraded yet, please do so very soon now. Thanks. Congestion control also benefit Onion service operators. If you're an Onion service operator, you should absolutely upgrade to a version of Tor that has congestion control in it. If you're interested in reading more about the deployment of congestion control, Mike Perry has written an excellent blog post about the technicalities of this entire deployment and the awesome work the teams did with specifically with their simulation work to figure out which system to choose during the early phases of the development. Due to the denial of service, we've also been doing some things that we did not plan for this year. One of the things was to look into a potential proof of work system for Onion services. This will be a system that is self-detecting in that it discovers when something is happening to the Onion service and enables there. So we ideally don't waste resources unless there is some kind of pathological situation appearing. We've gotten some help from different external parties for this. Thank you very much for this. We have a Tor proposal called 327, which you can read more about this subsystem. This is not implemented yet, but we hope to be doing it very soon. Last year at the State of the Onion, I was talking about conflux that we were hoping to do this year. It's still on the schedule for being implemented and hopefully deployed soon, but because of these DOS things, we haven't gotten started with it yet. But for people who are unaware, the idea with conflux is that it allows you to create multiple paths through the network and rendezvous, so to say, at the exit node or at the Onion service entrance point and have a connection over there. This will ideally allow you to be able to choose the least congested path through the network, but also in case that there's network downtime in one of the paths, then your connection shouldn't be terminated because of that. This should also greatly benefit, for example, our future VPN product. One thing that I'm missing to say, we are going to ramp up our Onion service engineering capacity soon. So look out for our job advertisement if you're interested in working with C and Rust systems engineering and specifically on network performance. Then we will soon have a job opening for people to apply for. I believe the next one is Nick, who will talk about art, but first back to you, Isa.
Thank you so much, Alex. And yes, Alex is right. We are about to put job posts for people to work with Tor and help us develop Onion servers with the network team. So please look up for it. And now I'd like to invite Nick, one of the founders of Tor and who has been working on Arty, this super exciting project of writing Tor in Rust. Welcome, Nick.
Hello. So you've heard a lot about Arty so far today. I'm going to do a short little talk about it, tell you why we're doing it, what exactly it is, how it's been going, what's coming up next, and how everybody can help. So Arty is a project to re-implement programming language. Why would we want to do that? So our main problem is that the C Tor implementation is pretty old and gnarly at this point. We haven't done a bad job, I'd say, but we've made a lot of decisions over the last 20 years that made sense at the time, but might not make a lot of sense in 2022, like using C in the first place, like being mostly single-threaded, like running primarily as an independent daemon process with just an afterthought towards being embeddable, like having a hard time running on mobile and making assumptions that don't hold on mobile. And as we try to fix these things and grow the Tor implementation, we find that it's hard and slow to do that because the existing implementation is a bit hard to work with, and the security issues that you need to avoid in C mean that we need to go even more slowly and carefully as we develop. Over the last, I guess 8 years at this point, we've been tracking all of our C security issues, all of our Tor security issues as they come up. And we found that almost 2/3 of them are things that are either directly due to memory unsafety in C or things that wouldn't happen in Rust for some other reason. We've gotten, I hope, pretty good at avoiding this kind of bug, but Still, avoiding them slows down development and puts a big barrier on development. So after a few different investigations and attempts, we decided that our best bet was to write a new project, Arty, to rewrite Tor in Rust from scratch. Rust is a modern programming language that gives you high-level behavior, C-like performance or better, with full memory safety. We found so far that it is much easier to develop than C, and it has a cute crab mascot named Ferris, which makes every day a little bit happier. I wonder if you can see my little friend over here. Yeah, here he is. They are. She is. Arty is our project to implement Tor in Rust. It's been modular and multi-threaded and completely embeddable in your own project since day one. So far, it's only client only, but over the coming years, we hope to add relay and finally authority support so that it can be the default Tor implementation for everybody. Where have we gotten over the last year? So at the start of last year, Arty was functional. You could turn it on and use it as a SOX proxy to connect to the Tor network. But the APIs were only sort of stable. You couldn't really recommend it for general use because it was missing some key security features. And there were lots of circumstances under which it would kind of run wild and download nonstop and fill up your network connection. So with a lot of work over the last year, we have gotten to Arty 1.0, which has stable high-level Rust APIs that are actually stable enough that other different projects have been able to embed Arty for Tor support in their own projects so far. We have a full suite of client-side security features, including, what you would expect from Tor: process hardening, channel padding, stream isolation, and so on. And another thing that we've been able to do in Rust that we were never able to do so easily in C is to test and simulate different kinds of network failures so that we could make sure that we were robust to all of them. So by simulating different kinds of network failures and making sure that Arty behaves correctly with them, we managed to get to a point in our confidence about reliability in the presence of weird networks that took us years and years to get to for the C equivalent. And there's more to come. Right now, we're working on our anti-censorship features. We should have them done really soon now, fingers crossed. That will include full bridge client and pluggable transport client support. And in 2023, in year 2 of our funding, thanks to the generous support of Zcash community grants, and of people who've donated, we need to get Onion services working as client and as an Onion service. We're going to have FFI support, foreign function interface, so that you can embed Arty not only in Rust programs, but in programs written in other languages too. And finally, we want to get to the point where Arty is ready to replace C as a Tor client for basically all uses and basically all users. We need help. One thing we really need is, if you think this would be fun to work on and hack on, you're right, it really is fun. Come on by that URL there and see what looks interesting to you. We need testing. Ideally, we need testing in the next year. People who can come on by and try building the software and try it out so that they can tell us about client-side bugs while we're still focused on the client side. It's a fun project, and we're all pretty fun people to work with on it, so why not get your Rust compiler and give it a shot? That's what I've got to say today about Arty, and I hope you'll be hearing more about Arty in the future.
Thank you so much, Nick. Excellent. Also, now I want to invite Hero, who is leading a metrics effort, and I want to also highlight the importance of her work and the metrics work, right? Like we have been hearing from the folks, right, like on the network health team, on the side of the anti-censorship team, right? Like for our development team, this is where we understand what's going on everywhere, right? Like, so it's extremely important work that we have for Tor. So I think I'm highlighting it because I would just want to make sure that folks understand, because sometimes people don't make the connection about how important it is regarding the metrics. So now, without further ado, we are having Hero jumping in.
Hello everyone, welcome to the exciting world of Tor network data. My name is Sylvia, aka Hero, and I'm a metrics engineer. If you want to reach out to me, you can send me an email or find me on the Fediverse. What does Tor metrics do? We collect network data and make it available to our community. This data is used by relay operators, Tor developers, activists, journalists, or simply put, data enthusiasts. The Tor metrics team is composed by just me, and it's part of the network health team. There are also a number of volunteers that contribute code, research, and bug reports. Metrics data is used for network health purposes, anti-censorship, or simply to understand what is happening in certain areas of the world where the net is censored and Tor is blocked. What we'll cover today: what happened in 2022, what is coming up next in 2023. In 2022, we updated how we count Snowflake users. We added various onion perf instances. We exposed the Open Metrics endpoint with aggregate network data. In 2023, we plan to update our data pipeline, deploy new onion perf Arty instances, provide better tools for data analysis to our community. When the Snowflake bridge was updated to use a sort of load balancer, we hit a limitation in our infrastructure where we were measuring just a fraction of the total number of Snowflake users. We had to update our pipeline in order to be able to count accurate statistics. This change was deployed at the beginning of October. Starting October 1st, we're now displaying accurate Snowflake statistics on metrics.project.org. During last year, we deployed various onion perf instances to measure at the same time different Tor versions and different Tor configurations. You might also have noticed that we deploy onion perf in different countries as well. This is important to test how release affects our users, where, and how. We have started exposing Open Metrics endpoint with aggregate data about the network and its users. You will find aggregate data about relays and bridges on your new Open Metrics endpoint, listed below. On our website, we have instead exposed an Open Metrics endpoint about aggregate user data, listed below as well. This one uses a simple linear prediction model to spot trends per country. If you really use Prometheus, you can add these endpoints and start exploring the data yourself in Grafana or in your favorite tools. More information is available on our wiki, but do not hesitate to reach out to me directly if you have questions. What's coming up next? We have been planning an update to our pipeline. We want to be able to better process our data, but also allow researchers to better use this data. Tor metrics pipeline is composed of many services, and in order to keep maintaining them all, we want to reduce the complexity of it too. This means update different parts of our infrastructure, but also maybe use less ad hoc services and be able to reduce how much code we have to maintain. We also want to have a better historical understanding of the network and be more agile in spotting trends and events as they're happening. At the same time, we hope to add more tools for researchers, but also provide more different visualization on our website. As Arty becomes more mature, we want to start measuring Arty performances and deploy onion perf Arty instances alongside Tor instances. Eventually, our goal is to provide better tools to our community. We want to improve access to our data. Up to now, we were providing the CSV on metrics.tor.org and the Tor boson collector. I think you can expect more Open Metrics endpoint exposed and more search or filtering capabilities on your new or current JSON endpoint. Ultimately, we want to reduce the time to insight for people interested in Tor network data. Thank you, everyone. I hope you find this interesting. And if you have any questions, please feel free to reach out to me directly.
That was Hero. Thank you so much. And you can see there's a lot going on the metrics world as well. Now I want to invite Jim, who works on Shadow or Network Simulator. Hi, Jim. Welcome.
Hi, Isa. Thank you. So yeah, I'll be talking about the Shadow Network Simulator. This is joint work between the Tor Project, Naval Research Lab and Georgetown Security Lab, and is sponsored by the National Science Foundation. So Shadow is a tool aimed primarily at developers and researchers, and it can be used to simulate networks running Tor and other applications. It emulates the operating system, allowing it to run the actual application binaries, so just Tor, and routes traffic through a model of the network. So unlike tools like NS3, for example, instead of having to build a model of your application, you can run the real application and then run it through just a model of the network. So this is useful for developing such applications, including Tor and applications using Tor, and testing out different scenarios and potential changes. This year we had about 2.5 full-time developers working on Shadow. We've made a lot of great progress, merged over 500 PRs, closed over 80 issues, and done 2 major releases, or not major in the December sense, but 2 releases. There's been some quality of life improvements. There's now significantly improved reporting. So now you can use the progress flag to monitor progress at like a console while logging, storing the log somewhere else. We now store a separate like strace style log if you just want to look at syscalls. We have tools making it easier to debug with GDB, even when you have like hundreds or thousands or more processes running. This helps you attach to the right one. And the simulations run faster. So a lot of the work we've been doing is expanding support for applications. In the past, Shadow, like in early versions of Shadow, you had to compile applications specially to work with Shadow, typically patch them and recompile them. None of that's needed anymore. And we've significantly expanded emulation functionality so that many applications work just out of the box. So of course you can run Tor. Now you can run Arty, which is the Rust implementation of Tor. We've run the Snowflake pluggable transport and many other network applications. So now when you want, instead of having to, whereas before we had to use like a specialized traffic generator inside these simulations to pipe traffic through Tor, we can still do that, but we can also now actually put the applications that are using Tor inside the simulation and evaluate that performance. And whereas before, in earlier versions, we mostly targeted C programs, now Shadow works with applications written in many languages, including like interpreted languages and JITted languages like Python and Java. It even works with Golang, which took some work, but so the Golang programs do need to be dynamically linked. That's typically pretty easy to do, and many these days are dynamically linked by default, especially network applications. To get all that extended compatibility, we've done a lot of work to expand Shadow's emulation support. So the actual interposition of how we intercept syscalls has gotten a lot more stable and complete. So now we use seccomp to ensure we catch every syscall, and we now patch the VDSO section, which is a loophole in a lot of such systems. We now have a feature to escape so-called busy loops. This has been a problem in previous versions of Shadow where sometimes a program will wait for time to pass before releasing control, and which would lead to deadlock in your Shadow's time model. That's no longer an issue. When you use this feature, we can kind of escape those loops. And we've implemented things like abstract named Unix sockets, Unix signal handling, and many more syscalls. A lot of what we're doing now is migrating Shadow to Shadow itself to Rust. It was previously written in C, which, with all the fun that brings with it, it's now we've migrated over half of it to Rust and are continuing on. The build is now mostly cargo-based rather than CMake. We've implemented, I think, some interesting abstractions to make this possible. We've implemented safe abstractions around shared memory, which Shadow uses for efficient interprocess communication, and implemented a new cell we call rooted cell to sort of do a directly model Shadow's ownership model in Rust and do kind of cheap atomic-free reference counting and interior mutability. So for Tor, Shadow is becoming an increasingly useful tool. We have used it over the last year to iteratively develop and tune the congestion control algorithm, which was launched in, I think, March, May. And as previously mentioned, this has greatly improved throughput for Tor. And after launch, we've continued to use it to tweak that algorithm, as well as evaluate potential mitigations against some of the denial of service attacks that others have talked about. We're now also using it in the continuous integration, the continuous integration testing of Arty. So now whenever we have a Arty merge request, we actually run a simulated network inside Shadow using the new Arty and making sure it actually works integrated with the current Tor and a simulated Tor network. This year, we're continuing to work on migrating more code to Rust. In particular, the goal is that new code should be straightforward to implement in Rust rather than in C. And that's becoming more and more the easier thing to do. We're also reworking the network stack, both evaluating its accuracy, rewriting it in Rust, adding additional tests to double check the accuracy of that network model. And we plan to add support for fork and exec, which will further expand the applications that Shadow can support, including shell scripts and servers that use fork. We're not sure if we'll make it into 2023, but another goal on our roadmap is to start modeling CPU execution time, which would allow us to kind of detect when things are CPU bound and actually model performance when things are more CPU bound than network bound. Thank you very much. Back to Isa.
Thank you so much, Jim. So we just saw, right, like people presenting from different teams that are building different tools that help us execute our work. And now I'm very happy to invite Arnakat, our TPA team lead, who is responsible for the tools that we use on every day to work here at Tor. So welcome, Arnakat.
Hi everyone. Thanks, Isa. I'm Anarkat. I'm the senior sysadmin at the Tor project, and I'm gonna show you around the sysadmin land. As Isa said, what we do is we take care of the stuff everyone else uses to build Tor. So that means managing a bunch of physical machines and virtual servers, responding to incidents and problems when they happen, and upgrading and installing machines. And we have a bunch of services we manage ourselves, but we also help other people manage their own services on that infrastructure. So who are we? We're basically 6 people, sorry, doing this, 3 paid staff and 3 volunteers. And this is roughly what we do. So this is the second time I do this presentation. So I'm going to do a little comparison from last year, where we had about 100 servers. Now we have 5 less, but we have 15 more physical servers. So that's an interesting situation. That's basically servers we haven't yet completely used. So there's some capacity there. We have 1 more point of presence. So that's a place where we host our servers. 30 web servers, since that's roughly the same as last year. We have our own homegrown bespoke CDN right now. We have more mail servers, about the same memory and bandwidth used than last year. We have more capacity in terms of memory on the servers, and we solved a lot more issues than last year, like basically 25% more or something, or a third more, like 100, depending on how you count. And we have this process where we have this workflow where tickets go into the backlog and the next, and then there's stuff we do, and when we don't do something, they go in the icebox. And I tend to think that everything ends up the icebox and dies there, and we forget everything. But we only have 11 more tickets there, so that's really encouraging. We still manage a lot of services. 23 of those services are managed by us. That's one more than last year, and 50 are managed by service admins, and many of those are undocumented. So there's a lot of legacy that we're taking care of. Major events last year, we retired some services. The Jenkins server has been replaced with GitLab CI. There's been Nginx caching servers we don't need anymore, and FB Central was also retired. We adopted 2 new services, the payment gateway for Bitcoin and the survey service, which you might have encountered. We upgraded a large part of our fleet to Debian Bullseye in the last year. We hope still to finish that by the end of the year. We end-of-lifed Python 2 as part of that process and cleaned up stuff in Nextcloud, designed a new mail services. Unfortunately, those, well, or fortunately for me, maybe, those are going to be outsourced in the end. The web team worked on the screenshot you see here is the Onion Launchpad. It's a splash page for when people need to access a service over .onion services. The web team also worked on the BridgeDB front end, and we drafted many proposals. So part of how we work is instead of having one person just calling the shots and imposing everything on everybody else, we tried to come up with a process where we can get opinions from people and have a more dynamic conversation. So we actually proposed a total of 31 such requests for comments, or TPA RFCs, I call them, in the last year, which is a lot. A lot of them are still in draft, but that's still a major change. Those are the RFCs. I'm not going to go through all of those, but it's basically, it gives you an idea of the stuff we do. And that process has been working pretty well. I'm a little overwhelmed right now with the draft column. I have like about 6 of those that I'm still trying to figure out, and some of those are pretty complex work, like changing all the email services and the monitoring and all sorts of things like this. So this is I'm gonna just end quickly with the roadmap review of last year. I showed this roadmap when I did that presentation, and we did a lot less than we expected, to be honest. We did retire a lot of services, but there's still a lot of work to be done there. I already talked about the Debian Bullseye upgrade. The new high-performance cluster might actually come in the next year. Now we've got some good progress going on that, but unfortunately we didn't get to clean up a lot of stuff for the sysadmin code base. I had hoped to show you the preview of next year's roadmap, but I'll leave that as a teaser since we haven't adopted it yet. You can see more information on our work on the GitLab wiki, and I think that's it for me. Back to you, Isa.
Thank you so much, Arnakat. And yes, thank you for the amazing work you and your team does. As you all can see, there's a lot going on inside of Tor. And now I would like to invite Al, our fundraising director. Hi, Al, welcome.
Hi, thank you. Hi, everyone. I'm Al. I'm the fundraising director at the Tor Project. And I'm here today to talk about our year-end fundraising campaign, the theme of which is powered by privacy. You have probably seen some of these graphics around your social media perusing of Tor, or about Tor in Tor browser, or on our website or donate page. And I wanted to explain a little bit about why we chose this theme, what it means, and what you can do to support the Tor project and ensure that everything that all of my colleagues have talked about continues and is sustainable. So why did we choose powered by privacy? I want to talk a little bit about why privacy is important in this moment and why privacy matters in a world where we're facing rising authoritarianism. If you're here in this watching this live stream, you probably know, or at least have a sense, that global internet freedom has declined for 12 straight years. We're seeing governments implement blackouts, more harsher and more frequent censorship. We're seeing private companies spy on their workers, both in and out of their homes. We're seeing children and students being monitored whenever they're using any kind of school device. And we're seeing that the data that's collected by these mechanisms can be scooped up by data brokers and easily and cheaply sold to governments and police. We're also seeing that when legal contexts change, these privacy violations have really dangerous impacts. For example, when Roe v. Wade was repealed, we saw that texts and web searches and online activity has immediately been used to prosecute people for seeking abortions. So we know that we need privacy. We're seeing violations that make it difficult for us to exercise our human rights. And Tor and privacy that it provides is an antidote to these violations. Privacy makes resistance, change, and freedom, and fighting for freedom possible. So that's why we chose this theme this year and why privacy is so important in this moment. Against these adversaries, it can feel, it can be easy to feel kind of hopeless. Our adversaries are big and we're tiny. So how do we win, or how do we fight back? Compared to big governments and their surveillance capitalism industry, our budget is really tiny. But just because we're small doesn't mean that we can't grow. And just because we're small doesn't mean we can't be successful, because we have something that those entities don't. We have each other. We have a community. We have the Tor community. And this community knows the power of its support to change the course of history and to make an impact in moments where it really matters. Something that's happening right now is internet freedom being severely restricted in Iran during the ongoing protests. And we're seeing our community step up in a big way to promote Tor, to make sure that people have it when they need it, and to run things like Snowflake proxies. At the end of October, I think we had around 30,000 Snowflake proxies, and now we have around 110,000. So our community stepped up in a big way to make Snowflake more accessible for the people who need it in urgent moments. We see that our community promotes Tor and actively shares information about how to be private online and how to circumvent censorship in moments of need. Here's a screenshot from a moment a couple of weeks ago when Tor browser was a top free app in Iran. We also see that when we call on you in other circumstances, you step up and recognize the need for internet freedom and demonstrate your values by contributing to the network. Last year, we hosted a call for more bridges, and this was around the same time that Russia implemented harsher censorship and blocking of the Tor network. And we saw that everyone stepped up and added hundreds more bridges to the network than we expected. So it's really awesome that when internet freedom is on the line, the Tor community can make a real difference. And there's other ways that you can help Tor continue its impact. And one of those things is with regular donations. In the same way that running a Snowflake proxy is something that you turn on and continue through time, turning on a regular monthly donation helps Tor do this work. It helps bring privacy to everyone who needs it. And it allows us to fight back against these larger entities that may have more resources but don't have our community power. So I know that me saying a monthly donation to Tor is awesome, only goes so far. So I wanted to reach out to some of our longest monthly donors and ask them, why do you do this? And what impact do you see? to share about how important this is. So I'm just going to share with you some of their answers. They've given me consent to share this. I asked the question, why do you donate monthly? And one donor answered, Tor is an important project that I value. Anonymity and privacy on the internet are essential to protecting the most persecuted and various minority populations both inside and outside the US. We all must have the ability to communicate without personal consequences. Another donor said, I love to support Tor because we need a private communications network for all kinds of reasons. Tor is a system that encourages freedom of speech and also provides an opportunity for people to learn how internet communications actually work. This one is great. This donor said, privacy is near and dear to my heart. I'm also aware that projects like this take a lot of time and effort, often from very smart people who could make a lot of money working in a big corporation but choose to do this. So if I can help a little, I gladly do that. I only do this for a few organizations that provide me with a free product that works well and has a privacy focus, like you guys. I think this really speaks to probably what you've heard throughout this stream today, is that we've got some pretty incredible people doing amazing, innovative work on Tor, and doing it in part because they believe in this mission. And your support of the Tor project makes that possible. And then this is the final one I'll share, because I think it really sums up why this matters. This donor said, I donate monthly because in a world that continues to go downhill, where governments seek to suppress their own citizens and try to invade their privacy, a network like Tor is the most valuable weapon for defense that an ordinary citizen has. That really just, that sums it up for me. I believe in this mission, and I think there are a lot of people here who do as well. And a monthly donation, no matter the size, right now will be matched by Friends of Tor. So if you start your monthly donation today with $10, it will become $20 automatically. And that's pretty awesome. And we also have some great new swag that's just been released. We have a tote bag for the first time, very exciting. I'm super excited about that. And you can find all of this on donate.torproject.org, where you can become a monthly donor, or you can donate one time. You can donate via credit card, PayPal, cryptocurrencies. And if you have any other ideas or you want to give back in some way, you can reach out to me directly. My email address is smith@torproject.org. I'd be happy to hear from you. And we're really grateful for your support. You make Tor possible. Thank you.
Thank you so much, Al. And we are at the end of our stream. So I just want to thank everybody who stayed so far with us. And I hope you enjoy all the updates that we shared. As you can see, we've been quite busy this year, and we have big plans for 2023. I'll have already, shared the importance of giving, the importance of donating. So I want to use this time at the end of our stream to highlight two cases from our community. They are very important right now for everybody to pay attention. One of them is Free Allah. Allah is a member of the community. Allah helps other people to learn about Tor and using Tor during the Egypt uprising and the Arab Spring. He is an amazing person who has been unfairly in jail for way too long, and he has been doing a hunger strike for over 200 days, and recently entered a completely hunger strike without any food or water whatsoever, which is extremely important that we support his struggle and the fight for justice on his case. Please look it up, the hashtag Free Allah when you can. And support the cause, support Allah, make his case known by everybody right now, especially as we are entering the COP27 in Egypt. All the attentions are in Egypt. We need to make that case heard. And the other case is the case of Ola Bini, another contributor to the community who is facing trial tomorrow, continuation of his trial, or not tomorrow, I'm sorry, this Friday on November 11th, Please also look up the hashtag #FreeOlabini to understand his case and all the unfair charge that has been put against him that he's facing in Ecuador. I think it's important to highlight that. I think it's important for us to build solidarity. That's why I'm using this time and then, not to ask for you to support Tor necessarily, but to support our community members who are in need right now that, really need our support and our attention to their cases so we can bring justice for them. I want to end reminding people that next week is the time to have the stream from the Tor community with many different projects that are doing very important work, bringing apps, to make it easier for people to use Tor. And then we'll be talking about that, and we should be supporting them as well. I'd like to thank you again for staying with us at the State of the Union. I hope again that you enjoy the stream, that it gave you an opportunity to learn a little bit about our teams and the work that we're doing, and so the support, and I thank the support from our community. You heard from everybody, right? Like we could not do what we do without you. And I would like to call you again to support Ala and and Olabini as well, two important cases that are happening right now. So please take a look at those cases and support them as well. And thank you for supporting the Tor project. Have a good day.